Yeah, hi, I'm Walter Wagner. I work in physics and many other fields of science, and I've been working with some of the people involved with the Large Hadron Collider regarding some of the risks that we've seen that are posed by this machine.
In 34 kilometers of tunnels and caverns the size of cathedrals at over 100 meters underground, CERN hosts facilities for experimental physics.
Well, I happen to live here in this beautiful setting of the Big Island of Hawaii. I'm as far away as you get. If you want to see where CERN is, I look straight down between my feet, and you go down about 8,000 miles, and you come out on the other side of the planet. That's where CERN is. There is this machine called the Large Hadron Collider that has been developed in Switzerland and France on the border between the two countries. It's abbreviated LHC. And this machine is essentially a particle collider that will collide atoms together head-on at energies higher than has ever been done before, and trying to create conditions that have not been observed since the beginning of the universe.
In CERN's accelerators, we can recreate conditions that existed just after the Big Bang and shed light on such questions as, why do particles have mass? What is the nature of dark matter in the universe? Why did matter triumph over antimatter in the first moments of the universe, making our existence possible? What was the state of matter just after the Big Bang? 4 gigantic instruments called particle detectors will study the data from the LHC collisions in search of the answers to these fundamental questions.
And there are some concerns regarding this, that it might be able to create new kinds of particles that have not been in existence either, and that some of these new particles might be dangerous, and that's what we've been concerned about. In particular, there's a particle called a strangelet, which is a new kind of atom that they are going to try to make at the Large Hadron Collider by colliding 2 lead atoms together. Normal atoms are composed of up quarks and down quarks, and they form the nucleus of the atom, the protons and the neutrons. And this new kind of atom would be made up of up quarks, down quarks, and strange quarks, and that's why it's called a strangelet. The difficulty with doing this is that a strangelet is believed to be a more stable form of nuclear matter, and it would potentially have the capability of engaging in a runaway fusion process with other normal atoms, and over the course of many centuries to millennia would be able to slowly fuse with the atoms of the Earth and convert the Earth into one large strange atom, releasing energy and in essence exploding the planet. And that's a consideration that we have been trying to bring to the attention of some of the people at the theory group at CERN, and they have so far essentially been ignoring this. And we're concerned that this is something that should not be done until we know that creating a strange atom is a safe thing to do, and we don't know that yet. There are theories out there that show that it might not be safe. People have searched for strangelets. They've searched for them in nature, believing that maybe they're created by cosmic rays striking the Earth's atmosphere. Haven't found them. They've searched for them at lower energy colliders and still haven't found them. And the intent is that with this much higher energy collider, they'll be able to create more strange quarks and finally create this quark-gluon plasma they've been trying to create, which will allow for the creation of this new kind of atom. And we find that to be an extremely risky situation until we know that this is something that is safe to do. There are experiments that are actually planned that might be able to prove this safety, but they haven't been done yet. There is a detector called the AMS, which is scheduled for launch next year in 2009 to be flown aboard the space station. And if it detects strangelets, then we can know that they're safe because they haven't interfered with the Earth. That's an experiment we think needs to be performed first before we go around trying to make strangelets ourselves, which might be the very first strangelets ever made since the creation of the universe. There is another scenario also, and that involves the formation of what's called a microblack hole. And a microblack hole would be essentially 2 atoms colliding into each other and collapsing into a very small microblack hole. And this is something that has been theoretically considered, and it hasn't been ruled out entirely as something that would not occur. If it does occur, there are some theories that show that they do not evaporate and that they would hang around the Earth long enough to eventually consume the Earth. Again, this would be something on the order of centuries to millennia or longer. And there are some people who said, well, that's fine if it's it's going to take a few million years to devour the planet, or a few thousand years, we don't have to worry about it. And I don't think that's a valid analysis. Well, I'm trying to get them to recognize that there are these unresolved concerns about safety that need to be resolved before they do their experimentation. Well, we've gone to CERN directly, and they've been working supposedly at coming up with another safety report, but the safety report they came up with was inadequate. We've explained that to them. We've filed suit in court, and we're hoping that that will be able to continue. It was dismissed at the trial court level. The trial court judge said she didn't have jurisdiction over something in which the U.S. is only a 10% involvement. We think that 10% involvement is sufficient for the U.S. to have for the U.S. courts to have jurisdiction. That'll be an appellate issue. We are also expecting to have further avenues to pursue on this. I have got many people I communicate with, many scientists who are concerned about this as well. It has been a, quote, minority, unquote, because the majority has a lot of money behind them. They have a $10 billion experiment, and they use a lot of that money for their PR, trying to promote that what they're doing is fine, but they have not addressed these issues, and we're having to do it as a grassroots kind of a effort to bring these issues to the attention of the general public.